that embodied carbon is really becoming the rhinoceros in the room and has smashed through the front door, both from this organisational reporting point of view and also because there is a massive business opportunity if you can start to couple low embodied carbon homes and green finance.
Are you interested in embodied carbon accounting? What do you think about choosing lower emission building materials? How can we make business sense for embodied carbon? Stay tuned for answers from Tom Petty.
What is the future for cities? Do you want to learn more about them? Do you want to know how others think about them? Do you want to be part of the conversation? Then this is the right place.
Welcome to What is the Future for Cities podcast. Today I will interview Tom Petty, co-founder of CarbonTrace. We will talk about his vision for the future of cities, making business sense of embodied carbon, the difference between infill and brownfield developments, and many more. So let's start with a proper introduction. Tom Petty is a cleantech innovator dedicated to reducing embodied carbon in residential construction, one of the most significant challenges of our time. With a master's in architecture and a career shift to building architectural homes, Tom brings a rare blend of design experience, hand-on construction knowledge, and a data-driven mindset to the table. Passionate about solving complex interconnected problems, Tom thrives on dismantling challenges to uncover innovative solutions and better approaches. His work is deeply personal, driven by a commitment to creating a sustainable future for his two children and for generations to come. Tom's journey has taken him from architecture to the dark side of building and now to the forefront of cleantech startups, where he combines his practical and theoretical insights to lead transformative change in the construction industry. His mission is clear: to make tangible difference in reducing the carbon footprint of the built environment. And with that, Tom, welcome to the podcast.
Thank you so much for your time. I highly appreciate your appearance on the podcast. Let's jump right in. What does the future of cities mean to you?
It's a good and very broad question, and I'd probably contextualise it a bit with my little understanding a bit of the world. Trained as an architect, turned to residential builder, turned to the dark side very early on. Been building homes for the last 15 years. Fell down the embodied carbon hole about 5 years ago. And the future of cities for me, I'll try and tie back to embodied carbon because it is such a relevant part of a modern city and, for that matter, the urban sprawl that is not necessarily a city but is part of the equation. That, I think, will narrow down the conversation a bit more, and that's my little bubble or my little world, so it'll be more useful than anything else. To contextualise that further and understanding embodied carbon, what is embodied carbon? People understand the idea of emissions that are attributed to burning coal to make power to run buildings, and that's part of effectively operational emissions of a building. The embodied emissions of a building relate to the pollution, the CO2 that's put out to actually make the bricks, make the steel, make the concrete that goes into the building. It's not about the operation of it or how much heating and cooling is needed. It's about what materials have been put into the building and what the emissions profile of those materials is. In a nutshell, there are better people who can describe it in better ways, but that's how I describe embodied carbon. It's the bricks and mortar emissions. And the reason that this is a really interesting conversation, and thank you for having me along. It's really great to discuss this because often it crystallises some ideas in my own mind. Embodied carbon is the new kid on the block. Politically, socially, and from a policy perspective, operational emissions, that is how energy efficient a building is or a home is, has been top of the agenda, and probably rightly so, because building efficiency is super relevant for our own comfort as well as bringing down emissions attached to burning fuel for electricity and so forth. And the embodied bit has been left to one side, partly because it's quite complicated. Secondly, because there's been such a huge learning curve in the operational aspect that it's just not enough bandwidth to pick up embodied carbon. But embodied carbon is actually where the rubber is hitting the road as we speak. And that's because as our grid decarbonises more and more, the net emissions attributable to our operational emissions, that is how efficiently we run a building, are decreasing in their significance compared to those emissions which are actually needed to build the building in the first place. Some rough numbers, and no one really knows, but if 90% of a home or a building's emissions are attributed to the operational running of it, 10% is the embodied carbon. That's historically been very rough numbers. Basically, the operational emissions and pollution way outweighs the embodied carbon. But as the grid starts to become more and more renewable, that is now shifting, and they reckon there's a few studies out there. One of them suggests that in 2050, it will be almost entirely inverted, and that the embodied component will be up to 85% of a total building's emissions, and the operational will be 10 to 15. And you can imagine how this is possible if all of the power used to heat or cool a home is from solar or wind or whatever renewable source it's from. There's, in theory, no emissions attached to that. So the efficiency aspect will be less significant from a net emissions point of view. And what's left is, hey, have we just had to clear a whole lot of forests or emit massive amounts of CO2 in order to produce this stack of bricks or this massive concrete monolith or whatever it is? Embodied carbon, new kid on the block. And I think the future of cities really will start to capitalise on what this means. And where, more importantly, and this is where I'll try and focus the conversation, where the opportunities are if you start to consider the embodied carbon of a building at the start of it. The reason I say that it's the new kid on the block is that people are now really asking about it. A month or so ago, legislation was passed requiring large organisations to report on their emissions, their Scope 3 emissions, which includes embodied carbon. This will be in 2026 that the reporting period starts, but essentially, it is on the agenda now of the C-suites of all the big organisations who have this reporting obligation. And they're all running around saying, what's embodied carbon? How do we spell it? How do we measure it? Where's our embodied carbon guy? And a lot of them are getting their sustainability consultant from the broom cupboard, shaking them down and saying, we need an answer by lunchtime. The honest truth is embodied carbon is the Wild West. No one really knows how to calculate it, what it is, the right way to calculate it, and where to draw the line there. I'll drill into a sort of example there. If you're trying to calculate how many emissions were attributed to making one brick, for example, where do you draw the boundary or the scope of the analysis? So you start at a clay pit. You've got a bloke who digs the clay out of the ground and puts it in a truck. So there's fuel attributed to that process. There's transport getting it from a clay pit to a brickworks. They have some electrical processes that make it look like a brick, and then they cook it at high heat for a period of hours. And all of those processes create emissions, and you can calculate those emissions and say, all right, one brick is 0.6 of a tonne or whatever the metric is for that brick. But it gets a bit tricky when you start thinking, who's the bloke that drove the machine? How did they get to site? Did they drive a big V8 ute to site emitting a whole lot of pollutant? Were there 6 people involved in that? What sort of toothbrush did they use in the morning? Like, you can start to stretch the analysis in insane lengths to try and really pin down every bit of emissions. And that's largely diminishing returns, but also it lends itself to this lack of consistency around how to measure it. And what that ultimately means is, globally, people can't be absolutely convinced on what the emissions profile of any material is. People are having a guess, and there's a thing called an environmental product declaration where suppliers will go through the process of trying to calculate that down to the nth degree. But that's a relatively new little moment in our history. And then you consider that a building is made up of, bricks and concrete, but screws and nails and light fittings and toilets and wire and everything. And if you want to understand the emissions profile of every bit of a home, which in theory is the objective, that is an enormous undertaking. And this is how I fell down the hole that 5 years ago, where I was building a home, a young child, and suddenly thought, hey, what's the environmental, what am I doing about the environment? Am I going to be able to look at my son in 30 years when he's looking at some smoked out city and say, hey, Dad, what did you do? And am I happy saying I just kept on building my own houses and put my plastic bags in the separate compartment and tried to recycle? Is that really what I'm... Or can I say, no, I had a small company. I made conscious business decisions to try and engage with this because I saw value in it from an ideological point of view. and also tried to develop value in it from a business point of view. So I started to say, all right, I build tricky architectural homes. Why don't I submit a project tender with a carbon price attached to it as well as a dollar price? So when I try and win the job, I say, hey, this job has got 60 tons of carbon in it. I've actually found a few ways you could build it in a slightly different structural system, and I can pull that down to 20. Here's a metric. And in order to do that, I had to start calculating and forecasting what the emissions profile was of a brick or a concrete or a stick of wood, and found it very difficult 5 years ago because there was even less information than there is now. And I also found that at the end of it, I had this number which meant nothing to anyone, including me, because there was no relativity to the number. We ended up with 87.6 tonnes, and everyone's looking at it like, oh, is this good? Is this bad? I don't know. Is it a win? And no one knew, no one could tell me. There was no benchmark, there was no scaled way of doing it. All there was seemed to be hundreds of different approaches yielding totally different numbers. Therefore, how do you have confidence, or why do you engage with a number full stop? That was really quite interesting to arrive at that point. Yes, I've done the process of trying to calculate embodied carbon, but it didn't mean anything because I was maybe too early by about 5 years. But also because there's not enough global understanding of what this means or why an owner should care. And that's really the key bit of it. And this is where one of my companies, CarbonTrace, which is the cleantech hat that I wear. So I went from architect to residential builder and then to cleantech entrepreneur, trying to build this. It wasn't called CarbonTrace then, but I was trying to develop a way for designers to engage with optimizing carbon emissions as they were designing. Because what I found characteristically was I'd come up with emissions reductions. Hey, if you change the structural system and put in this bit of bracing here, we could actually take 6 tonnes of CO2 out one way or the other. What I would invariably get is, thanks for your exercise, but we've already got the documentation done. It'll cost us money to change it, so do what we said. And I kept seeing that again and again and was continually disappointed that somehow as a builder who was quite close to an understanding of how you could bring down emissions, I was also way too late in the process. And so the first iteration of CarbonTrace was trying to optioneer at very early stage some of the big picture structural decisions. Could I use a slab on ground with screw piles instead of fully blinding stuff for all sorts of build optimization reasons? And so I built this nerdy little algorithm that was totally impalatable to anyone except for me. And I got another 6 tons out of whatever. No one cared. Absolutely no one cared. It was cool. And then I'm sort of 6 months or maybe 12 months after doing this, I got involved with MECLA. It's a cool consortium or coming together of anyone who cares about embodied carbon across Australia. An amazing organisation fronted by some incredible people. And they welcomed me with open arms as this weird bloke who'd stepped off a building site and had done all this carbon nerd work. And I was suddenly exposed to a whole lot of other people who understood what I was trying to do and why. And I felt less like I was a little nerd in a basement and more like part of a movement trying to solve the problem of the future of our built environment, the future of cities, how you could deal with embodied carbon emissions. And through that, ultimately, I met my business partner, Ben Cryan, and together we formed proper CarbonTrace. His background was also muddy boots. He's a civil engineer, and he had an optioneering platform to do value engineering and carbon engineering of linear infrastructure projects. And he had a SaaS platform and a tech team, tech stack that had built out a pretty slick-looking thing. And he said, hey, we should talk, because he saw there being opportunity in the residential space. And he's got a brilliant mind, as an engineer does. And it took him a little while to pull me around on the idea that, Tom, embodied carbon's a lovely ideology, but if you can't make business sense out of embodied carbon, it will remain a cottage industry concept. We need to scale this. We need to engage with this at another level. We need an enterprise level SaaS platform that everyone can start to deal with, not just a little nerd in a dungeon. And that was really inspiring to work with him and have his support, and then suddenly have a tech team who are helping build out stuff, and stuff pops up on a dialog box on the internet. Wow, hey, this is awesome. This looks like real. Wow. And suddenly this embodied carbon journey that I was on changed gear altogether. So Ben really was fundamental in taking me out of the weeds in a way. And what we arrived at, this was in 2023, I think. We started 23, I think. We came together and started to really make this a bit real in that we identified fairly early on that if heaps of people couldn't engage with embodied carbon and if it remained out of reach of the common mere mortal, it was a waste of time talking about it because you couldn't achieve decarbonisation at scale. It would remain essentially a consultant's role insulated by other consultants in their own little echo chamber. And that was not an ultimate ideological objective for me and didn't make business sense for him. And so we pretty early on said, all right, how can we take what you've done and make this big, make this hit every building that makes up a city? And there was a moment where we suddenly realised that had to be our objective. And the idea of perfection and chasing every light switch and counting every screw had the negative effect of limiting the scale that we could approach. And instead we revisited the idea of what is the way we could capture a city worth of houses? Where is there a data flow that we could grab a city worth of data and try and make embodied carbon analysis from that, even if it's imperfect, as a way to start this exercise at scale? Bit of mucking around with this algorithm that I'd built, and I heard a podcast, I think, of Anthony Wright from CSIRO talking about one of the home energy efficiency things. And I said, hey, CSIRO, they administer the NatHERS certificate, the energy certificate process that every home in Australia effectively needs to go through to get a building permit, to describe that their energy efficiency of their home is up to scratch. That's a process that is administered by CSIRO, and I thought, hey, that's quite an interesting data set because it's massive and built into the system and standardised, all sorts of advantages. So I just banged on the door and said, hey, Andy, here's what we're doing. It'd be great to chat. And he, again, opened the door with open arms, was like, we'd love people to start unpacking our data and love what you're looking at and how can we help? So we ended up developing a way to use CSIRO data to convert the energy efficiency certificate attached to every house into embodied carbon data. That meant we had suddenly 1 million data points. Every home that had been built in the last 6 years, we had a data stock on, which we had run through our algorithm. And we'd produced, we thought, and we still think, Australia's closest thing to a residential sector embodied carbon benchmark. Imperfect, because anything to do with embodied carbon is imperfect, and NatHERS is imperfect, and everything's imperfect, including my algorithm. But we had done this imperfect thing 1 million times. And that gave us confidence that the starting point, our initial problem that we'd identified, that, hey, we need to do this at scale, we had cracked that nut. And that was a big win for us, to be able to see this number drop out and all this data get ingested and spit out the other end. And wow, that actually works, which was amazing. And that's where CarbonTrace really started to hit its straps. We were 2 years early when that happened, and people were still running around trying to work out how to spell embodied carbon. And it was early days. We thought we had this great thing. And businesses were like, yeah, whatever, like embodied carbon. He plays for Hawthorn, doesn't he? That was the sort of engagement we had with it. And it fell by the wayside because we realised no one was that interested, because why would you? There's no commercial interest in understanding embodied carbon. And so we like, okay, that's a shame. Us two nerds think this is really cool. We've done it at scale, but what next? And that was where that commercial aspect came really at the forefront. How could you convert this data set into something that meant money for businesses? And it's taken me maybe 6 years to fully embrace the concept that while you can start with sustainability as an ideology initially, and it's a sound starting point, from a business perspective, if it doesn't make financial sense, it is not going to happen. It's not going to scale, and it will always be hogtied by that. And so I now shift the lens entirely and have been trying to work out how embodied carbon and what embodied carbon in cities means for an organisation financially. As we've been doing this, Ben and I have been doing this over the years, the landscape has shifted dramatically under our feet from an embodied carbon context. There's multiple other tools have produced emissions databases, and policymakers have started pointing to it. Some councils have started adopting embodied carbon as a screening metric. Building ministers more recently pointed to the National Construction Code and a voluntary reporting of embodied carbon, at least for the commercial sector. Alison Scotland and others have produced some amazing reports pointing to the importance of embodied carbon, which has been received well by industry, and policymakers are now scurrying around trying to work out what do we do, how do we do this. So what that means is the literacy has gone from very low to very high, which is where I think there is opportunity now to tackle embodied carbon as part of a future cities play on two fundamental and fairly experimental grounds. And I say experimental because it is early days, and this is not really my area of expertise, although I have fell down this hole sideways and down another hole to end up here, that there are enormous buckets of sustainably earmarked finance that exist globally. And how can you create the financial architecture or the data architecture to try and quantify, put a metric around the embodied carbon of a building in a city with the key objective of accessing this green finance? Because if you can say, hey, we've built a lower carbon building, and because it's lower carbon, we can access cheaper cost of capital, our mortgage is cheaper. That then takes embodied carbon out of the realm of the total esoteric and very much on the kitchen table of the mum and dad who are thinking about the home they want to buy, build or renovate. Embodied carbon can and should be a metric for assessing sustainability, simply because there's such a huge range of materials you can choose from with very different emissions profiles. Therefore, it becomes a matter of choice, both from a designer perspective as well as a homeowner perspective. Do I choose to have a lower carbon product and therefore perhaps access cheaper money? Or look my children in the eye and say, hey, we made a conscious decision in the house we built to measure the carbon and try and reduce it as much as we could. And that's not possible unless there's a metric. That became our end goal. It was quite a journey, and it's still an ongoing journey. I can't say this has been cracked whatsoever. But the idea that you can empower people with data or an emissions profile, allowing and empowering them with the decision to do one or another. Do we really want a double brick wall with a suspended concrete slab? Do we really care if we could halve the embodied carbon emissions with a weatherboard or a lightweight home or a well-insulated timber structure? Oh, hey, we don't really care. If a floor's a floor, a roof's a roof. If it's airtight and windproof, cool. Hey, does that mean we also get $1,000 off our mortgage a month? That, to me, seems like a way to engage with decarbonisation at scale, beyond as an academic exercise, which I've wasted a lot of time on managing it as an academic exercise. So there's a whole lot attached to that, and I can elaborate on some of those bits maybe a bit later. But again, trying to zoom out and consider embodied carbon as a way of that can shape the economic decisions made behind what cities look like. That's one obvious play. The other obvious one is that the ESG reporting that I think I mentioned earlier, for big organisations, they need to start worrying about their embodied carbon because they have to report it to ASIC. That is the other play where data is becoming very important, and understanding of emissions, because it's one thing to understand, hey, our organisation emits 6,000 tonnes of CO2 a year. Everyone's objective is to get to zero. Everyone wants to be net zero. The whole country needs to be net zero emissions. So in order to get from whatever your starting point is down to zero, you need two things. Firstly, you need to know where you're starting. What is your benchmark? And secondly, you need to have a way to interface with that data, that number, so that you can develop what we call glide paths down to your net zero target. Yes, I'm a builder. Hey, if I substitute my conventional concrete for low carbon concrete, I can get 30% of the way to this net zero objective. I can stage that over 2 years. I can map that. I can plot that. I can do a cost analysis on it. I can demonstrate to my shareholders, I've got an ESG target. I've got a goal. I've got a way of measuring it. Here's something real and tangible. That's the sort of application we see being quite useful for builders and to an extent developers. But the big elephant in the room are the banks, because the banks have to report on the emissions of their entire portfolio, including their loan books. So any residential home that has a mortgage behind it forms part of their emissions profile. And most of the big banks have signed up to PCAF, which is a global consortium of finance players that are basically saying, hey, we need to do our bit to bring down emissions. we're financing all sorts of great stuff and terrible stuff. We need to do more good stuff and less bad stuff. They've all signed up to this, have these objectives, and have no way of measuring or engaging with embodied carbon at city scale that we see. So again, once you start getting a bank interested in understanding their emissions, and more importantly then shaping how they might offer a green loan for a sustainable home, trickling down to the mum and dad who might be able to shop around a green loan mortgage. So they might say, we want to build a sustainable home. We know that Bank X will give us a couple of percentage points off if we can achieve a sustainable metric. We can hit whatever yes, you've ticked this box, you are eligible for the sustainable loan. What is the criteria that sits behind that? And to me, that is where the data is necessary, and that is where the metric and the architecture is necessary for banks to start to engage with the mums and dads. Because contextualising that further, the mums and dads are the ones that have gone to their super fund and said, hey, we want you to divest in fossil fuels. We want you to invest in sustainability projects, and we're moving our super fund because that's now our focus. So these big institutional investors, these super funds, are being told by their membership, hey, we need to invest in sustainable stuff. They are the ones that banks borrow money from to finance the mortgages. So it's closing the loop in a way that mums and dads have pointed to where their super money is kept, said this is for sustainable stuff only. Banks have a metric for measuring what is sustainable with particular focus on embodied carbon, so that mums and dads can see that their choice is actually translated in, right now, relieving cost of living pressure or a cheaper home to buy or build. So it's taken us a while to arrive at the point that the decarbonisation at scale really needs to boil down to dollars, and the hard bit is creating the link and enough meaning in that measurement and enough confidence in the data. It's no small task trying to move and get a system that's recognised by financial institutions as a metric. But once our grid is fully green, the only emissions that are left are our embodied carbon emissions from a built environment point of view. And while I can't say this too loudly, Tassie's an interesting example because their grid is basically all green. Or it's hydro and they're exporting renewable energy. So they're a good example of a precinct or a territory where their emissions associated with running a building are effectively zero, in theory. And therefore, the only stuff left is the embodied emissions. So it's like a nice glimpse at what a city looks like in 50 years from now, except right now no one's grappled with that and what that actually means from a net zero point of view. So it's an interesting test case that embodied carbon is really becoming the rhinoceros in the room and has smashed through the front door, both from this organisation reporting point of view and also because there is a massive business opportunity if you can start to couple low embodied carbon homes and green finance. It also ticks the other, and this is where my builder's hat is quite useful, the modern methods of construction or prefabricated building typologies are becoming more and more mainstream. And by their nature, they tend to be lightweight structures. A lot of timber, very little brick because it's hard to prefab in brick because it's too heavy. And typically not a slab, it might have a lightweight floor system, a cassette floor system, which means it has a very low embodied carbon profile. Because from a residential home perspective, the slab and masonry walls do most of the dirty work from an emissions point of view. So to put on your builder's hat and say, hey, prefab home is good for a whole lot of reasons, quality control, speed on site, ultimately cost and quality and so forth. It's also got an embodied carbon profile that is fantastic. So then it hits multiple kind of objectives. It's got all those great things from a build perspective, but if it also opens up the green finance play, it's cheaper. So you've got better quality, in theory lower cost, quicker build, you've got lower environmental emissions, better for the environment, and it's cheaper because you've got green finance tied to it. You could not hit a better suite of, hey, whoa, this solves a whole lot of problems. And the bit that's missing, or has been to date, is a way to measure embodied carbon in a way that's consistent and scalable and not just a one-man band operation. And this is why we ended up at CSIRO and using a federal scheme and massive set of data, because the way we have been grappling with that consistency thing and to say, let's do this at scale, is that if you can arrive at an industry benchmark derived from a massive sample size. That is every new home that's been built in the last 6 years. Let's say you can do that, but you're not quite sure what the emissions of a brick is. Because if you look at you go to 6 different scientists, they'll give you 6 different answers of what the emissions of a brick is, or a bit of timber, or a block of concrete, or whatever it is. No one can agree on that emissions factor. And waiting for someone to pin down the correct emissions factor that is globally accepted will be like waiting for Godot. It is just not going to happen. You have to accept that is the landscape and will be the landscape for the next 5 or 10 years. But if you have that in the back of your mind and say, if you can do the same thing 1,000,000 times, you can arrive at a comparison against benchmark. You can start to compare one project against many using exactly the same metric. So yes, maybe you picked a different emissions factor for a brick, but you used that factor 1,000,000 times and you used the same factor to compare that one home. So what you end up with is at least some consistency in methodology and process, which is, I think, what is necessary to create confidence and say, legitimately, the decision to build all in timber and not in brick translates as a substantial improvement against a benchmark. And that delta off benchmark becomes the metric rather than the pursuit of an absolute value. To my mind, chasing exactly that absolute value of a home as a single number is somewhat of a folly. And there's a lot of heat around which databases to use. To my mind, it's really muddying the water in a way that's unnecessary. If you accept that they are all different, they are all perhaps correct in their own way, but are for different purposes, then you can exclude that from the conversation and say, we've at least got a quantity component, that is the number of bricks, the amount of concrete, and the amount of framing. That is now a consistent, reliable value. And we could use all of the databases. We use 10 of them. Doesn't matter. You can compare them all. They will probably all say exactly the same thing, which is build with less concrete or build with low carbon concrete, and where you can build in lightweight structures, or particularly timber, because obviously, or perhaps not obvious for a lot of people, but timber is made up of CO2 emissions. It is the ultimate material from a sequestering perspective because it has sucked it out of the air to be turned into structural material that is then incorporated in a home. It is not only an offset, it's a drawdown. What you expect is that all the databases will point to materials like that as preferable to carbon-intensive materials that involve high temperature to produce the material or have travelled a long way or whatever it is. You expect all the databases to arrive with that same consensus. So if then the future of cities looks like a series of choices made by designers, by engineers, by homeowners, by builders to say, hey, I can reduce the emissions profile of this home and make it look heaps better than the benchmark. And I know that if I do, say, 20 or 30% better than the benchmark, I know I'm suddenly eligible for green finance. That then starts to turn on the entire equation. Because then builders are interested in building low carbon because they can offer a cheaper ticket price on their home. Mums and dads start asking the question, what is your benchmark? How does the Dorothy 6 compare to every other home in the suburb? Because I've heard if it hits 30% below on this metric, I can get cheaper money. Then they start asking a question. That means the builders start going to all of their material suppliers and say, hey, we keep getting asked about this embodied carbon stuff. If you've got an EPD, and could we pin down some low emissions products so that we can get this 30% or whatever it is? Builders don't even have to worry about how to get there, what it is. No one has to engage in that nerdy measurement thing. You've just suddenly got a box that you're trying to aim for. And that's what designers are good at. That's what volume builders are very good at. And that works at scale. So then your suppliers are starting to shift to renewable sources so they can put their hand on their heart and say, yes, this is a lower carbon product, and yes, it will bring your emissions down, and you'll sell more homes because they're green homes. That is how this happens at scale. And that whole ecosystem is, for better or worse, comes back to money. And so it's creating that framework, that architecture that allows that metric to be used, which is where I see the future of cities really changing and the urban form really changing because people are informed by data. People have choice that is equipped with numbers behind it that are credible or convincing, rightly or wrongly. the number might be what it is, but it's the same number that's been used a million times to our mind. So yes, we need to get better and better material emissions data going. But while that journey is happening, we can still start. And at the time of the interview, the Neighbours team have released their stab at the Australian emissions database for the commercial sector, which is solving that problem of consistency and the right number to choose. So we just see that improving and expanding underneath the feet of this framework. So therefore, the framework has to be able to adapt to it. If you lock it into one particular typology and it changes, the database changes, then the whole thing falls over. You just have to treat it as quite elastic, I think.
Thank you so much for describing it so much detail and the whole circle, which helps us understand how embodied carbon matters for new builds. How does embodied carbon matter for existing built environment?
Really interesting question. So the idea that I think you're pointing to here is that best thing you can possibly do is not emit CO2 by having to build new bricks and new concrete. Use the stuff that's already in a building because the emissions are already done. So we shouldn't be demolishing them and putting them in landfill. We should be trying to get more out of those emissions that we've already expended. Really interesting idea because it starts to put a metric around the value of renovation or a retrofit rather than a knockdown and a rebuild. And I think that's probably the cleanest way to talk about it a little bit. And it is really another rabbit hole that I've been less stuck down it because exponentially harder, effectively, to try and grapple with existing building stock and embodied emissions, because what is the emissions profile of a brick in a home? Is it a home that was built in the 1800s and the brick was been around for 120 years, and they would be bricks that I use every day? Second-hand bricks, salvage. Does that have as effectively zero emissions profile, minus the transport cost and so forth? Probably. Maybe. But then what about a building that was built 10 years ago that made of brick? Does that brick have a zero emissions profile? What if it's a home that was built 1 year ago? Does that then have a zero emissions profile? So do you then have to treat the embodied carbon of materials as a depreciating asset? You suddenly end up thinking, well, this is hard. How old is the building? What's the anticipated service life? Has it effectively fulfilled its purposes? Objective 1, house 1, hey, we can extend the lifespan, that utility of that material by another 100 years by doing a tactical renovation, keeping it. I'm all for that in a huge way. I think it nods towards circular economy in a massive way. But it is very hard to quantify, given that it's already hard to do it for new stuff. It's hard and it's not hard. It's not hard at a one-off level, but it's very hard at scale. And that's been our limiting thing. How do you consistently do an audit of an existing building? How do you consistently audit what is being retained, what is not? Quantify that. It is possible, but doesn't fit inside the NatHERS CSIRO data set that is not captured currently, which means it's data that needs to have a framework to collect that raw data, that metadata to begin with, which in theory can be done. That's where an architect could very easily have a bill of quantities, have a way of capturing exactly what was kept, how much was saved by keeping a thing. It can be done. It's the scalability and therefore its ability to function as a financial lever, because it needs a robustness behind it. Makes it a slightly spreer subject, but a really interesting one. And it talks to another question, slightly tangential, but I think a good one, is that if you've got a building, if you could understand the emissions of a building, how do you assess the metric? If it's a home, let's say it's got 100 tonnes worth of emissions in it, and it houses 2 people. How does that compare to a home of 100 tonnes that houses 6 people? From a functional operation perspective, you are housing more people for the same amount of emissions. That is a good thing. We are satisfying population density, and to use those numbers, in one home, one person equals 50 tonnes. And if the other, 6 is a hard number, but say it's 5 people, one person is 20 tonnes. So what that suggests to me is that in understanding and unpacking data, you can arrive at a number of different metrics, which should hopefully point us towards building smaller homes, which can fit more people for the same area, for less emissions. But the way you cut that number can vary a lot. And this is, again, why there's no agreed methodology for how to cut that number. Do you do it by the square meters of house? Maybe. But then a really big house actually looks quite good from an intensity point of view. It's 100 tons, but it's a 1,000 square metre house, one of those monsters versus a very small house. A tiny house that's 30 square metres and still has an environmental load of 50 tons. If you do that on a square meterage house, it tells you build bigger homes, which is the wrong direction. You need to have metrics that can be used to steer a meaningful decarbonisation, not end up with these perverse outcomes. The reason I tie it back to your question on existing stock is if you can keep 3/4 of a home and only introduce an extra 10 tonnes of CO2 to achieve a building with another 50-year lifespan that's housing 4 people, not 3 people, then that is a very high yield 10-tonne emission compared to knocking it down and building it again. So that's where cutting the data in a particular way can really shape and should shape the embodied carbon as a screening tool used by designers and specifically local governments. We see a world where every new home has been compared against the suburb average and it's logged that, this is 20% better than the suburb average from last year. That's hitting the glide path. We're heading in the right direction. And there should be a big red flag going up if a home is being built with an unjustified double brick suspended slab embodied carbon nightmare, which is 50% worse than the suburb average. Unless there's a really good reason to build that way, we should not be building that way. LGAs, local government authorities, should be able to use this as a metric to try and understand their own portfolio and steer it down. Work on hey, you've got a really well-performing home, 30% below average. There's actually a fast track lane over here for projects that have hit our sustainability metric. We'll turn your planning permit around in 4 weeks. So again, a commercial application, because that is time is money, for understanding an embodied carbon and being able to say, hey, we took conscious decisions or we spent more money in design or material procurement to deliver a lower carbon home, but we have a return on that. We can now quantify it and we can peg it to dollars and we can say, yep, this is money well spent. That's the landscape I see future cities moving into. And I see it happening in the next 5 years. Comfortably in the next 5 years, to be honest. The reason I say that is there are already green loan products out there by all the major banks and some of the smaller ones for putting things like solar panels and batteries and charging stations. It's targeted loans hitting an energy efficiency aspect of the build already exist and the framework exists for it, but they don't touch embodied carbon yet, partly because there's no way to measure it confidently. And I think chicken and egg and the donkey before the cart or whatever the expression is, you need to keep an eye on the fact that all those energy efficiency initiatives are fantastic and great at stimulating the change we need, and we need that to happen in all directions. But really, we should start. Someone should be getting an eyebrow raised at embodied carbon and really point to that and say, hey, look, if there is a way to measure this at scale and convincingly, it can hit a whole lot of things. And if we can offer a green loan product that satisfies that, then that's a good thing. And from a bank's perspective, I just can see it as a win because they have a few objectives. They want to get more customers. So if they've got a competitive product that a customer can point to and say, I'm going to run with you instead of this other, but that's a win. So engaging with embodied carbon, if that's the metric, that's another way to get bums through the door. It also allows them to start gathering specific data on embodied carbon, which they need for their embodied carbon ESG reporting, their Scope 3 reporting. And it also allows them to start to deal with their glide path and reducing emissions by saying, we are preferencing a mortgage of a sustainable home over an unsustainable home because it's hitting our glide paths better. If they get clever and tie up the basis point reduction that they can get and translate that into a lump sum at settlement, then the homeowner moves in and has got a green loan product, and as a result of it has effectively a cash bonus when they move in, instead of having that small basis point reduction spread out over a 30-year mortgage time, which I think a lot of people think effectively day to day, week to week. If you could aggregate that up and receive, that is a massive incentive point to try and go for one product over another. It also means that banks can effectively lock people up with that cash incentive, making it very hard for them to change banks, because to do that, they would have to be foregoing or refunding that cash bonus. And again, these are conceptual ideas that we've spoken to banks and anyone who'll listen about. And we just see a huge opportunity in a landscape ripe for this, and one that is very new because for the first time, there's a way of measuring embodied carbon at city scale.
So let's focus on the new developments for now. And I would love to understand how can we compare new developments on the fringe or in the suburbs and new developments in the CBD or in the centers. So is there a general metric which would tell us that on the fringe is better or in the brownfields in the city are better?
You have to get into the specifics a little bit to understand why. If you operate on the assumption that a concrete slab and or the wall, the external masonry wall, is doing most of the dirty work, and you consider a single-story large home with a large footprint on a brownfield site, as opposed to a small footprint 3-story townhouse in an infill site, you have proportionally less concrete slab for enclosed building area and proportionally less wall area. So from a net material or like a dematerializing point of view, you've got much more efficient use of the high emitting products, you're using less of it. What it does, if you start to measure it, is effectively say that strategic density translates as a much better emissions solution than large spread out masses of building, which purely from a CO2 emissions perspective are a bad idea. Not even considering all of the land use change impacts and the fact that it's a house instead of a forest, or you're taking away all the other metrics that you could use to assess, haven't even been part of that equation, and it's still a bad idea. And then you can add to that, and this is where we see its application from a planning perspective, you can then start to do a cost analysis for an infrastructure emissions outlay, if you want to call it that. It could be a costing outlay, to say, hey, in order to service this brownfield site of homes that are not performing terribly well from an embodied carbon point of view, we need to put a 4-lane road out there and chop up a whole lot of other stuff. We can now make a reasonable case to say it is better for us to increase density in a controlled way and avoid that spread out morass of embodied carbon, as well as the infrastructure required to service it. And we have a metric to start to reward sensitive infill site development. And I think the commercial sector is starting to get their heads around this. But what I would be really interested in seeing is the Class 2, the multi-res developers starting to capitalise on this. And I think they will fairly early on when they understand they can measure it, to justify density on the grounds of embodied carbon.
Very interesting, because you just mentioned that the developers could capitalize on increasing the density. And that's, again, a very good business sense on how decreasing carbon emissions increase the revenues who develop those sites. One last question regarding the materials, because you were talking about timber. And we are talking in Australia, although the audience is global, Australia has seen fires, big fires. How is building with timber connected to the bushfires in Australia?
There's a slight difference that needs to be made between an out-of-control bushfire of native forest and the horrific emissions of CO2 attributed to that versus the controlled and sustainable management of a forest that's designed for harvesting. Native forests going up in smoke is less about built form. You're not building with that wood. That's wood that's for nature. We need that to exist in an untouched way. The fact that the forest fires are so catastrophic talks to issues that are absolutely not my field of pre-planning for fire. How can you manage forests backburn properly, and crossing into the fact that our homes are starting to overlap on forest areas. There's a few aspects there to separate. The point that I'd like to stress, though, is that if you've got a industry that can effectively and sustainably, and it can be done sustainably, and there are great examples in Australia of well-managed forests that are used for harvesting on a 30, 50-year cycle that we are getting structural timber out of. Those are the forests that we need to keep an eye on as the solution to a drawdown to an emissions drawdown. Because the more of those forests we grow and harvest and lock up in buildings, thus making them not vulnerable to bushfire attack and so forth, that is a win. That is sucking CO2 out of the atmosphere. That is heading in the right direction. We've got however many parts per million. Every tree we stick in is sucking a few out. So I think the key point to focus on there is plantation timber and its capacity as a material is very different to native forests that, for whatever reason, not being managed and the bushfires are ripping through them. I think you need to deal with both things, but you can't muddy the water and say they're the same thing. They are very different things. And sustainably managed forest is our solution. If there is a solution, it's that or it's some other very fast-growing crop that can suck out heaps of CO2. Because how else are we going to do it? We're still waiting for in-ground CO2 sequestering to be a thing, and people get cooking up tricky ways to suck CO2 out of the air. But we've got trees. Mother Nature worked it out ages ago. Just get more of them. Heaps of them. And get more out of your tree. Because if you can stimulate that supply side and really push businesses to invest in that and to do it well, and by doing it well, maybe that's locally grown stuff where we can be sure of the environmental credentials and can really be in control of it. That's jobs in Australia, that's growth in Australia. It's a huge opportunity and one that I think the Timber Group are aware of, but it is perhaps getting navigated in different ways by other industry groups that might have a material that doesn't have a drawdown capacity. I won't name names.
And we could use also bamboos, not
Bamboo,
just
100%.
timber.
Fast growing, drawdown, more of it.
Okay, Tom, you have been very generous with your time and answers. As a last question, although I could ask you for hours, to be honest, maybe in the next round, do you have any closing comments or requests for the audience?
Closing comment would be that this needs to be dealt with now because it's good business. And if you are not dealing with it and getting your head around it and learning how to spell it and learning what it means for your business, you will be left behind. That, I think, is the reality. The worst case is that policy will eventually build a stick and that will hurt. But the better play I see in the short term is for industry to work out a way to benefit from incentives. And if that comes from the ingenuity of industry and particular sectors to capitalise on this sort of coming together of many, it's the sweet spot right now. Now is the time to engage with it and try and find those opportunities. So I'd say that's broadly relevant to organisations, and at a mum and dad level, I think it's understanding that this is something you can ask. What are you doing about embodied carbon, builder? Do you have a way of measuring it? Have you ever measured it? What would happen if you did? Those questions that come from demand side will help industry work out, hey, people keep asking about this. Does it mean if enough people call the bank and ask for a green loan for a home, someone in the bank will eventually be like, hey, Brian, do you reckon we should pass this up the line? Yeah, why not? It really is, yes, get your solar panel, get your battery, your EV, all that stuff. Fantastic. Do it 100%. But the big play, I think, and the big opportunity is at least starting to ask the question, understand your choices and what the implications of your choices are, but be informed. It can come from, I think I saw a beer on tap the other day that was carbon neutral. And that's the start of making this meat the butcher. Now carbon neutral, that's now a branding thing. So suppliers are starting to see it, which means if customers keep asking for it, it'll become more and more mainstream. And that is the way for everyone to be a part of this equation. You don't have to be a carbon nerd. To all the other carbon nerds out there, hats off for your work. I learned so much from everyone. And I've also learned that if you get bogged down in the detail, it's very frustrating and hard to move. So don't let perfection get in the way of progress. That'd be my sort of closing comments for 3 very different sectors of our cities.
Tom, please keep up the good work, and I just love that you transformed your nerdiness into a business which others can use and be empowered by. So thank you so much for today, and thank you so much for your work.
Oh, thank you for having me. It's been a great pleasure.
It was really interesting to hear from Tom why embodied carbon is the new kid on the block. Not to mention his conviction of lowering Scope 3 emissions. Alan Pierce described Scope 1, 2, and 3 emissions in detail in episode 196. You can find out more about Tom online. All the links are in the show notes. What was the most interesting part for you? What questions did arise regarding Tom's approach to the future of cities? What have you learned from this interview? Let me know on Twitter at WTF4Cities or on the WTF4Cities.com website where the transcript and show notes are available. You can also subscribe on the website not to miss any new episodes and leave some feedback. I hope this was an interesting interview for you as well, and thanks for tuning in.
What is the Future for Cities podcast?